Welcome. In this lesson, we learn how to use the sign of the first derivative to determine whether the function is increasing, decreasing, or constant. Now, in this example, for example, we have like a part of a graph that is for a function that is increasing, and this part is for a function that is constant, and this part that is for function decreasing. So relation between derivative and decreasement, for example, we have here uh, f prime of x negative. So when the function is decreasing, f prime of x is negative. Vice versa. When the derivative is negative, the function is decreasing. And here, the derivative must be positive. So f prime is positive. And here the f prime must be equal 0 when the function equals constant. Okay. Now we are going to have a question. F of x equals 2x plus 1 over x squared. We are asked to find the domain and the intervals from the domain where the function is increasing, decreasing, or constant. Now my function is 2x plus 1 over x squared. The domain is where the function is defined, can be calculated. It can be calculated for all values of x except 0. So all in numbers except 0. Now we need to derive the function, differentiate. So I put it on this form to use the power rule instead of the quotient rule. You can use the quotient rule as well. Now deriving would give, for 2x I get 2, and for x power of minus 2 I get minus 2, x power of minus 2 minus 1, which is minus 3. So this is my derivative finally. 2 minus 2 over x cubed, x power of minus 3 becomes 1 over x cubed. Okay, so we have two common factors, as you can see. We take it out and we get here common denominator, x cubed. So we multiply 1 by x cubed, I get x cubed minus 1. This is the simplest form that's going to help me to find the sign of this derivative. Okay, now we study and we look for the roots of this derivative and its sign. The roots is where the function is 0. So we put f prime equals 0. As you can see here, 2 cannot be 0, and the fraction would be 0 when the numerator is 0, which is x cubed minus 1. So I get x cubed minus 1 equals 0. Solve it to get x equals 1. That's the only root. This root is actually a critical value for the function. To get the sign of the derivative, we consider the critical value, this value 1, and the value 0 from the domain. We said all real numbers but 0. The function is not defined. As well, the derivative is not defined. We always include this when we study the sign. Okay, so I get my number line. I put my values, my 0 and the critical value 1, and then I look at these three parts. This part, values of x less than 0, and this part between 0 and 1, and this part for x more than 1. So for the first part, x less than 0, I take any value less than 0. I choose minus 1, you can choose any value, and I substitute in the derivative. I get 4. As you can see, I'm interested in the sign. This derivative is positive. F prime is positive when x is less than 0. For any value you substitute here, you get it positive. So the function is increasing, as we state here. F prime positive, f increasing. Now we go between 0 and 1. The value chosen is 0.5. Substitute in the derivative, we get minus 14. I'm interested in this sign. F prime is negative. So when x is between 0 and 1, the function is decreasing. Now I go for the values above 1. I've chosen the value 2 for x. Substituting derivative, you get 1.75. This is 75. This is a positive value. So for x more than 1, the function is increasing. That's it. We found all the intervals where it's increasing, where it's decreasing. Okay, and the critical value. Now I'm going to summarize all this in a table. So the table would look like this. Values of x here, the domain, critical value 0, that is outside domain. Derivative, the sign, we said a plus for less than 0, for x less than 0, a minus for x between 0 and 1, and a plus for x more than 1. It takes the value 0 at 1. The function fx here, this row is for your function. This shows that the function is increasing because the derivative is positive, decreasing here, increasing here. From this table, I can see that 3 is a relative minimum. How do I get 3? This 3, I get it from the function, substitute with 1. So f of 1 equals 2 plus 1, which is exactly 3. So 1, 3 is a relative minimum for your function. Now, it would be a good idea if you check this using a graphing tool. Any graphing tool, graph your function, thus enter this function and graph it. I'm going to see if this result is exactly what you see on the graph. Okay, this is my graph. So as you can see, the blue line is your graph. This part shows increasing function for x less than 0, which is this part. Increasing function. This is 0 on the x. This part is less than 0. Your function is increasing. For x more than 0, you have a decreasement, minimum, relative minimum, then increasement. This is your decreasement. This is your relative minimum. Can you see x equals 1 and y equals 3. 1, 3. And then increasement. So the graphing tools shows exactly what I got in my results. That means my results are accurate and correct. This is it. Now this is a question for you to try. The function is minus 2x plus 1 over x squared. Same thing. You have to find the domain and then where the function is increasing, decreasing, constant, and then the relative extrema, if they exist. Okay, I advise you to pause this video, work out this question, and then check your answer by watching the video again. You don't know what to do? Start with f prime of x. If you're not sure, go back and watch the previous question and then come back to see the answer. Hello again. This is your function. This should be your derivative after simplification. This should be your table that summarizes your results. Decreasing for x less than minus 1, increasing for x between minus 1 and 0, and decreasing for x more than 0. The point minus 1, 3 is a relative minimum, and this graph exactly confirms the result. Okay, remember, f prime decides on the increasement or decreasement of the function. If it is positive, the function is increasing. If f prime is 0, the function is constant. If f prime is negative, the function is decreasing. And that's the end. See you again in another video, and I hope this is going to help you to improve your skills in studying functions. Thank you very much.